Hi class, it's Miss Knoll from behind the screen. I hope everyone's doing well today. Welcome to class. So obviously I'm not there today, but I wanted to create a video just to sort of introduce the topic that we're going to cover, so that we don't lose too much ground just because I'm gone. So I want to just kind of finish up day 2. So we started day 2 last class, which I'll talk about in a second. And then you can practice the stuff from day 2, and then when I come back, if there's still some misunderstandings, we'll go over that, and then kind of continue on to day 3. So I know it's kind of been a weird schedule, but just sort of be flexible and roll with it, please. Okay, so last class I know was a little weird because of the PSAT, kind of a funky schedule, but I guess our class was still at the normal time. But anyway, so I know a lot of people weren't there. But what we did last class was kind of finished up factoring by grouping. We took a little daily check on that, so you'll have to make that up if you missed it. But anyway, and then we went on to the beginning of day 2 notes, which was factoring quadratic expressions when you had the a value equal to 1. So the a value is, when you have standard form of a quadratic, it's ax squared plus bx plus c. So whenever the first term is just simply an x squared, then it's actually pretty easy to factor. What you do is, step 1 says you look for two numbers that multiply to give you c, which is the constant, and add to give you b. And then you factor that into the quantity of x plus or minus whatever the number is, and then times the quantity of x plus or minus whatever the other number is. So for example 1, we had to factor x squared plus 7x plus 10. So since there's the constant in front of x is just 1, a equals 1, that tells us we're just looking for numbers that multiply to 10 and add to 7, the middle number, in front of x. So we have multiplying to 10, adding to 7, so we found that those numbers would be 5 and 2. So then we take those numbers, put it in here for x plus 5 times x plus 2. And then right here is just me foiling it back out to show that this x plus 5 times x plus 2 actually equals x squared plus 7x plus 10. So that's the point of factoring. We're just breaking it into its factors. It's an equivalent statement, an equivalent expression. So the remainder of last class was just sort of going over that and doing some practice problems there. So now I'm going to skip ahead from there and let us talk about section 2 on day 2. So this is factoring quadratic expressions in the form of ax squared plus bx plus c. So that's standard form when a does not equal 1. So whenever you have some coefficient on the x squared term that is a number different than 1, you're going to have to use this method to factor, or at least this is a good method to use to do this. So what we want to do is we take a, the number in front of x squared, and we multiply it by c. Now this is going to give us the number that we're looking for, that it's going to multiply to. So you know how before it was like, oh, numbers that multiply to this, add to this. So we want numbers that multiply to a times c. And we still want them to add up to give b. So that's the the coefficient in front of x. So then what you do is you split the expression into ax squared plus whatever number we found times x, plus whatever other number we found times x, and then plus c. And then we take that expression and we factor it by grouping. So let's do an example because, like I always say, math makes much more sense in examples than in words. So looking at example 1, we have factor 7x squared minus 2x minus 9 by grouping. So the first thing we always want to look for is there GCF? So we're like, oh, 7x squared minus 2x minus 9. No factors are shared there, so there's not a GCF. Okay, so next thing we look for is what is the a value? So that is the coefficient on the x squared term. So we see that here a equals 7. So that tells us that we need to use this method because a is not equal to 1. So we need to take 7 and multiply by the constant, which is negative 9. So we're looking for numbers that multiply to 7 times negative 9, which would be negative 63. And then, but they still add up to the b number, b value, which is negative 2. So we're looking for numbers that multiply to negative 63 and add to negative 2. So after thinking about that for a second, we'd be like, oh, well, negative 9 times positive 7 would equal negative 63, and if you add negative 9 plus 7, you get negative 2. So those are the numbers I'm going to go with. So once you have those numbers, you're going to split up 7x squared minus 2x minus 9 into 7x squared. And it doesn't really matter what order you put them in. It should work out either way. But I'm going to go ahead and put plus 7x minus 9x minus 9. Then we take this and we factor it by grouping. So, excuse me, I'm going to look at the first two terms. So 7x squared plus 7 and factor out their greatest common factor, which would be 7. And I'm left with, oh no, I'm sorry. It would be 7x. So I factor out a 7x, and I'm left with x plus 1. So don't forget the plus 1. And then we have minus 9x minus 9. So I'm going to factor out a negative 9. And I'm left with x. And then if I take negative 9 divided by negative 9, I get a positive 1. So I have x plus 1. So now, after factoring by grouping, I have 7x minus 9 times quantity x plus 1. And then, boom, I have just factored, the quadratic, where a was not equal to 1. And I can always check my answer by FOILing this back out. So 7x times x would give me 7x squared, and then I have plus 7x minus 9x, and then minus 9. Combine like terms, and I have 7x squared minus 2x minus 9. So boom, that checks out. Totally works. So let's try another example here. We have 3x squared minus 13x minus 10. So again, first thing we look for is a GCF. I don't see one. So next thing I would say is, oh, okay, the a value in front of the x squared is 3. So I have to make sure that I multiply 3 times negative 10. So actually over here you can see that this was kind of already done for you. We have negative 30. We're looking for numbers that multiply to that. And then add to the b value, the middle number there, negative 13. So that would be negative 15. Oops. And positive 2 would multiply to negative 30 and add to negative 13. I know it might be tempting to have negative 10 and negative 3. Those add to negative 13, but the problem is that would multiply to a positive 30. So be very careful when you're coming up with the numbers that you want to use. Now, once you do this like a times c thing, this is really only, like this should only be in your x chart, okay? Like when you come back to this step where you're splitting it up, that 30 completely goes away. It stays this 10, okay? The a times c is only to find these two numbers. Once you find these two numbers, forget about the a times c. Forget about the negative 30. It's not coming back. So anyway, so I'm going to plug these values in here. So I have 3x squared minus 15x plus 2x minus 10. And then I'm going to factor by grouping. So the first two terms, I factor out the GCF, which is 3x. I'm left with x minus 5. And then here I factor out the GCF, which is 2. And I'm left with x minus 5 when I divide those out. And so now, factoring by grouping, I take these front terms, 3x plus 2, and x minus 5. And that would be my final answer. And again, you can always FOIL it out and check your answer for that. Okay, one more. Next example, 5x squared plus 12x plus 7. So again, checking for GCF first, always. Don't see one. So next thing, I look for what the number is in front of the x squared term. And notice that it is a 5, so that is not 1. So I'm going to have to make sure that I multiply 5 times 7 to give me 35. So that's the numbers I'm looking for to multiply to. And then add to the middle number 12. So 35 and 12. So that would be 7 times 5. Now I want to show this a little visually, maybe. So see how we split up? What we're really doing here is we're taking this 12x, and I'm saying, oh, well, 12x can be broken up into 7x plus 5x. Like, these are those numbers we found, and we're just saying that it's kind of like uncombining like terms. I think that's what I kind of say sometimes. You know, we're going backwards. So you're breaking it up into something slightly more complicated so that we can factor it by grouping. So then here I have the 5x squared, so that stays the same. And then plus 7 stays the same as well. So the only thing we did was just break up 12x into 7x plus 5x. And then we just factor this by grouping. And this is kind of a prime example to show that it doesn't really matter what order you put the numbers, or the numbers in. Like, because, you know, it would almost make more sense to put the 5x there. Oh, you can't see where I'm pointing. Put the 5x here and the 7x here. Just because it would kind of match up with the 5 and 7, but it really doesn't matter. This is fine the way I have it set up, because I'm just going to go ahead and factor out greatest common factor, and I'm left with 5x plus 7. And then here I have plus 1, 5x plus 7. Remember, if you see the second group doesn't have a GCF really, it's already, you know, the only factor it shares is 1, then go ahead and write that 1 so that you don't forget it when you have x plus 1 times 5x plus 7. And then that would be my final answer for that one. Another way you can do it is some people like to kind of set up a box. I'm a little whatever. I'm a little nervous about using the box sometimes, simply because if you forget to factor out the GCF first, the box method fails. So that makes me nervous just because, you know, it's easy to sometimes overlook a GCF and not factor it out. But if you do that and you try using this method, you'll do things right but kind of get the wrong answer, almost like an extraneous solution. A little different. But it's still a, you know, valid way to go about doing this. So you would have 5x squared, you would find those numbers that, you know, you would take 5 times 7, gives you 35. You're looking for numbers that multiply 35 and add to 12. Well, that happens to be those numbers that we found before, 7 and 5. And then what you do is you just factor out, or find the GCF of each row and column, respectively, and then kind of like write it above or beside it. So like the GCF of 5x squared and 5x is 5x. The GCF of 7x and 7 is 7. The GCF of 5x squared and 7x is x. And the GCF of 5x and 7 is 1. And then all of these are positive. You can kind of see that. So this is 5x plus 7, x plus 1. And so that is your final answer. So it's kind of just a way to factor by grouping a little bit visually, if you like that. Alright, so now I'm going to stop this video because I'm almost out of time, and maybe do one more short one where I just do a few more examples that you can watch, and then you can practice on your own for the rest of the class and finish up the homework for this day. Yeah. Okay, well anyway, yeah, so I'm going to pause this video and hopefully move on to the next.